Okay, so now we have this proper locomotion system, including cardinal direction based animations for both jog, walk, and crouch states. Okay, so now let's introduce new concept called animation warping, right? So the warping actually resolves the animation directions plus the amount of foot placement, right? So before going to the concept, I will explain the issue currently we have. So we have like 4 cardinal direction based animations. We have forward animation, we have backward, left, and right? But if I try to move diagonally, something like this, you can see it's still playing forward animation. And if I try to play diagonally like this, it's still playing the right animation. And same to this direction, same to this direction. So this is quite wrong, right? Because ideally what we need is when you are moving to the diagonal direction, the animation hierarchy should be able to resolve that specific direction and move the character towards that specific direction and play the corresponding animation. So in order to resolve that, we can introduce the warping, right? So in that particular scenario, we can introduce the orientation warping, right? So in order to enable the orientation warping, you need to actually enable a plugin. So you can go to the plugins section and simply search for animation warping. Yeah, so make sure this plugin is enabled, right? Because this provides set of animation and post warping features for us, right? So it provides this stride warping, orientation warping, slope warping, things like that. But I think mainly what we focusing is this one, orientation warping, right? Okay, so let's go to the ABP locomotion, and there let's start with the anim graph locomotion at the start state, right? So let me quickly look at my documentation. Yeah, so at the start state, right, we have this sequence evaluator to determine what is the corresponding animation that we are playing based on the cardinal direction, and we are updating the states accordingly. So now let's add orientation warping skeletal controls to here, and then we have to trigger this orientation warping whenever we are enabling or whenever we are doing the strafing, right? Because at the forward facing mode, it automatically rotates the character for that specific direction. Therefore, we don't need to enable the orientation warping. But for the strafing, actually we need this orientation warping. So this alpha can be used to control that logic, which means like if we are at the strafing mode, this alpha is 1, but if we are at the forward facing mode, then we are at alpha 0, which means orientation warping is not applied. So let's get the property access pin as usual, and there let's go to the get movement component, b orient rotation to movement. Actually maybe later on we can make a function to get this variable real quick. I think this movement component get orient rotation to movement is repeated in many places, but later on when you're doing the optimizations and improvements, we can figure that those things out. But for now, let's use this approach. So let's select float, right? So if we orient rotation to movement, which means we have the strafing, then actually orient rotation to movement, then we have the forward facing, then alpha should be 0. If not, which means we are strafing, then the alpha should be 1. Okay. Plus, when you're connecting these pins, actually you can drop the pin to here like that, but it will introduce a new pin called local to component, right? and let's plug the pins to here as well, so it's component to local, right? Okay, then we have the variable called local velocity here. Then we can use this local velocity direction angle with offset to determine the locomotion angle actually. So at the orientation warp, there are two types of modes that we can follow, either manual or graph. So I'll follow in the graph approach. So if you switch it back to the graph approach, it will give you this locomotion angle pin instead of the uh, orientation angle, right? So let's switch to the graph mode, and I can plug the locomotion angle pin here. And as the yeah, I think that would be enough. And we don't have locomotion direction. Yeah, I believe that would be fine. Let's compile and save. Yeah, you have to select the proper bones hierarchy as well, because what this skeletal control do is it rotate the specific bones based on the resolved direction that we are pointing out here, right? So let's add spline bones, right? So at the spline bones we need spine 1 to be rotated, and spine 2 and spine 3. Also do we have the IK hand root? Yeah, IK hand root, right? And as the IK foot bone, let's select IK foot, and as the IK foot root bone, and as the IK foot bones, let's select IK foot L and IK foot R, right? And the rotation axis should be 0, and maybe distribute bone orientation alpha, we can maybe make it as 0.75. root interrupt speed, I can keep it as 10, and I think rest of the stuffs are pretty much fine. Let's compile and save. Now that warning has been gone, now we can play test it. So whenever I try to move to that direction, yeah, you can see it rotates the root bone actually, right? But currently we added only this for the start animation, so it's almost unnoticeable. So let's add this to cycle as well. So I'll copy the entire thing. Wait, yeah, edit, and let's go to the cycle state. And there, before additive animation, let's apply this one, plug the pin, and you don't need this alpha change, let's keep it as 1, and plug it to here. Right, this one we don't need to use local velocity direction angle with offset. Instead of that, let's directly use local velocity direction angle, right? Now let's try to play again. Now we are at the cycle animation, Now you can see whenever we are moving to the diagonal direction, it rotates the root bones accordingly, right? So you can see for each direction now the bones are rotating, right? So no foot sliding is there. Actually we are playing only 4 animations, but we are rotating the bones accordingly, right? So it will feels like we are playing multiple different animations for each direction, but actually we are playing only one animation at a time, and all of those directions will be get resolved by 4 cardinal direction specific animations, right? Okay, so similarly for this stop, actually we don't need to mention a specific cardinal direction, but if you want you can add it as well. So let's say let's go to the stop, and here maybe I can add the same thing, right? So let's play it again, right? But it doesn't give any effect, right? Because it's pretty much instantaneous. So I think no point of adding stop to here, but just for testing, maybe let's try local velocity direction angle. I'm not quite sure, but let's try it again. Yeah, still it has no proper effect, right? So we can get rid of rotation warping at the stop animes, right? But for pivots, actually we can use the anim, right? Because if you see at the pivots, maybe the pivot can be driven for a like this direction, right? So pivot, maybe you can add this orientation warping, but the effect is almost insignificant. But for the safe side, let's add that as well. So let's add this one. We don't need these alpha changes. Let's keep it as 1 and plug it to here and here as well. Let's copy the same thing, go to the second state and paste it here. Okay, compile, save all. Let's play test it again. Yep, so the cardinal directions and corresponding orientation warpings are now properly resolved. And let's try the walk. Yep, walk also works properly. And for crouch, yes, again it works properly. Okay, so that's how we add orientation warping for our locomotion system. And let's do some improvements further in the next episode. Thank you. See you there.